more information about sections 7.5 and 7.6. We did both of these sections in class on Monday, but I just wanted to give everybody a review and go over a couple of the questions that we didn't quite get to in 7.6. So what we talked about was, we talked about these common ratios in right triangles. So this works for all right triangles. We have three common ratios that we talked about. We talk about the sine, the cosine, and the tangent ratios when it comes to right triangles. So let's get a right triangle up on here. Okay, and so let's kind of talk about the parts of a right triangle. So we have our right triangle. Oh, still on the wrong thing. There we go. A right triangle right here. And the side that's opposite our right triangle is called the hypotenuse. I'm going to abbreviate the HYP, the hypotenuse. So it's always the side that's opposite the right triangle. That is our hypotenuse. We'll go ahead and label this as A, B, and C. Okay, so we actually have these three terms, the sine, the cosine, and the tangent. And so let's just do a quick review of what those mean. And we're going to do all these relative to this angle A. Okay, so the sine, and if you remember, we said we were going to try to remember this by well, it's not an acronym. Is it a mnemonic? Yes. So we're going to try to remember it by SOHCAHTOA. So SOHCAHTOA. Okay, so the SO is for sine. So the sine of angle A is equal to the opposite side divided by the hypotenuse. Okay, so if we were trying to find the sine of angle A, and let's put some numbers on here. Let's make it a 3, 4, 5 triangle. Okay, so if we wanted to find the sine of angle A, we're going to go for the opposite side. The side is 3. And the hypotenuse is 5, because the hypotenuse is always the side that's across from the right angle. Okay, if we wanted to find the, let's change up our colors here. We want to try the cosine of angle A. We're going to do the adjacent side relative to the hypotenuse. That's the, so that's so, and then the is cosine is adjacent over hypotenuse. So the adjacent side of A means the side that's adjacent to it, right next to it. And someone asked in class on Monday, how do you know that this is the adjacent side, not this? Well, that is because the side that's the length of 5 is the hypotenuse. So that gets its own special name. Okay, so the adjacent side is going to be 4, and the hypotenuse will be 5. Okay, and then the last thing that we can do is the tangent. This is the TOA, SOHCAHTOA. So the tangent of angle A is equal to the opposite over the adjacent. Okay, and our opposite side is 3, and our adjacent side is 4. Again, it can't be the 5 because 5 is our hypotenuse. So that's a quick review of section 7.5 and 7.6 and what we talked about on Monday. And then we did a lot of work with that. So 7.5, we did everything with tangents. And in 7.6, we talked about applying the sine and the cosine ratio. So I don't think we got to our second page of notes on that. And so that's what I'm going to go ahead and do with you guys today. So let me clear this off. Pull this up. Okay, so first up we have a basketball court. You walk from one corner of a basketball court to the opposite corner. Write and solve a proportion using a trigonomic ratio to approximate the distance of the walk. Okay, so what we have here is we have a triangle. Okay, it's a 90-degree triangle. We know that one of the angles is 62 degrees, and we know that one of the sides is 94 degrees, and we have a missing side here. Now, if you were not in sections and you said, oh, okay, well, I think I'm going to use the sine, the cosine, or the tangent because I have an angle and a side and a right angle, and I should be able to use that information to go ahead and solve this. So how do I decide which one to use? Well, I'm going to use a sine or a cosine function because my unknown here, my x, is the hypotenuse, right? It's the hypotenuse. It's the, if I can make it h, it's the value that's across from my right angle. So I have to use sine or cosine because tangent is just opposite over adjacent. So that doesn't actually help me out in this. So it looks like I have 62 degrees and I have the opposite side over the adjacent side. So the opposite side over the hypotenuse. Opposite over hypotenuse is the ratio for sine. So the sine of 62 degrees equals the opposite side over the hypotenuse. So if I fill in my terms, the sine of 62 degrees equals my opposite side is 94, and my hypotenuse is x. That's what we want to know. Okay, so now we can actually solve this. If you put this over 1, this is a proportion that we've been doing a lot of. So I can say that 94 times 1 equals x times the sine of 62 degrees. And if I want to solve for x, I want to divide both sides by the sine of 62 degrees. Now, the sine of 62 degrees is a number, and it's always the same number. So you can use old school would be you can use a chart to figure that out, or you can use a calculator. So what we're going to do is we're going to use a calculator to calculate 94 divided by the sine of 62. Now, give me just a second here. I'm going to switch over to Desmos. So Desmos is a graphing tool. You can also, I know some of you are using your iPhones. So if I do 92 divided by, and my function here is the sine of 62. Now I need to do something before I know this is correct. I need to make sure that my calculator is in, there's two different functions in calculators. There's radians and degrees. So make sure that your calculator is in degrees because we're dealing with 62 degrees. Plus, that didn't make sense anyway. In radians, it said that the side was negative 127 feet. That wouldn't work, right? So 92 divided by 60, sine of 62 is 106 feet, about 106.5. So if we go back over here, this is 106.5 feet. And that seems right, right? This basketball court is 94 feet on the slide. So if you walked across the center of it, it's going to be longer. It's going to be 106.5 feet. Okay, so that's how we would do that one. Let's try the next one. Okay. So we got a roller coaster. You're at the top of a roller coaster. It's 100 feet above the ground. And the angle of depression is 44 degrees. About how far do you ride down the hill? So they've drawn this nice picture for you. We have an assumed right angle right here. They don't actually have it labeled on there. But we know that the angle of depression, that means how far it's going down from vertical, is 44 degrees. We also have our unknown x. How far is our roller coaster traveling? And that x is actually the hypotenuse. Oh, I'm sorry. The right angle was down here, so we can assume it up there. So that x value is the hypotenuse. And then we have an opposite side of 40 degrees of 100 feet. So since we have, again, opposite over hypotenuse, we are going to use the sine. So the sine of angle 44 is the opposite over the hypotenuse. This is the sine of 44 degrees equals the opposite side. Opposite of 44 degrees is 100 feet. And the hypotenuse is x. We don't know what that is. So we're going to do, again, cross multiply, right? So we get 100 times the sine of 44 and divide both sides by sine of 44 because this is just a number. The sine of 44 is just a number. And when we solve that, the signs cross off and we end up with x. And let's switch over to graphing 100 divided by the sine of 44. So okay, so we get 143.95. So basically 144 feet. So x equals 144 feet. And that seems about right? We've got 100 feet tall that you're at the top of the roller coaster, so the whole length of the side will be 144 feet. All right, on to the next example. Maybe we'll use cosine this time, right? So a railroad crossing arm that is 20 feet long is stuck with an angle of elevation of 35 degrees. Find the lengths of x and y. Oh, we get to actually use more than one. So what they've given us here is 20 feet is this distance right here. That is our hypotenuse, right? That's our term that's across from our right angle. So since they've given us our hypotenuse, we're going to probably use sine and cosine because tangent doesn't actually use the hypotenuse, right? So let's look at, we've got to do x and y. So let's do x first. Well, x is the opposite side. So that means that the sine of 35 degrees equals the opposite over hypotenuse. And our opposite side is x, and our hypotenuse is 20. Okay, so I kind of have this in the middle here, but we basically have sine 35 equals x divided by 20. And we need to cross multiply, right? So we end up with x equals 20 times the sine of 35 degrees. So we'll switch to our calculators, whatever you're using for that. So we've got 20 times the sine of 35 degrees. So we get about 11.5, right? X equals 11.5. 11.5. All right, now what about y? What about this length that's down here? Well, there's actually two options for y. One option would be that we could actually use the Pythagorean theorem, right? To figure out what y is. We could also use the cosine, because we haven't used that yet. So the cosine of 35 degrees equals the adjacent side over the hypotenuse. It's a little hard to see on there. So the adjacent side is y, and the hypotenuse is 20. So that means that y equals 20 times the cosine of 35 degrees. And let's flip back over and find out what that would be. (16.4), let's say. So y equals 16.4. Now, if we really want to be geometry nerdy, what we can do is we can check the Pythagorean theorem and make sure it works out. So remember, the Pythagorean theorem says that x squared plus y squared should equal the hypotenuse squared. It actually was a squared plus b squared equals c squared. But so if Pythagorean holds true, 20 squared should equal 11.5 squared plus 16.4 squared. So let's go ahead and use a calculator for this. 11.5 squared plus 16.4 squared gives us 401. And the other side we have 20 squared, which is 400. So that's pretty close since we did some rounding, right? Pretty close to the same value. Technically, I think this was 383, but there we go. Get a little closer when we get more decimal places. Okay, and then there is one last example I want to do with you, which actually brings in information from 7.4. So I think it's a good review. It says, use a special right triangle to find the sine and the cosine of a 30-degree angle. So if you remember, we talked about 30, 60, 90 triangles. And the side that is opposite the 30 degrees, the smallest side and the hypotenuse are double each other. And the middle side is times the radical of 3. So basically, they've drawn a 30, 60, 90 triangle right here, a basic triangle. And so a 30, 60, 90 triangle will have the side lengths of 1, and then the middle side will be square root of 3, and the hypotenuse will be 2 times 1, which is 2. Okay, so if we want to find the sine of angle 30, the sine, if you remember, is so it's opposite over hypotenuse, which in this case, the opposite is 1 divided by 2, or 0.5. So the sine of angle 30 is always 0.5. The cosine, that's the c, right, is the adjacent over the hypotenuse. The adjacent side is square root of 3 over 2, which is about 0.866 if you do square root of 3 over 2. So then if we go to our graphing tool and we do the sine of 30 and the cosine of 30, actually it's just a calculator tool, right? Sine of 30 degrees is always 0.5, and the cosine of 30 degrees is always going to be 0.866. Okay, so that is just some extra information if you need some extra help on those sections, and we will finish up 7.7 on Monday, and I hope you guys have a great weekend. Bye.